Assalamu alaikum. My name is Ali Al-Khamis. I am the group leader for Group 1, where we will be looking at student academic performance in relation to factors such as self-study hours, attendance, and participation. My group members are Muhammad Akroof, Abdul Wahab Al-Shiha, Ali Al-Yusuf, Hamad Al-Ufan, and Ali Buhamad. So what is the main problem? There are many at-risk students who are at risk of failing. So using these mathematical models will help us identify these students and help them improve their performance. Our objectives are analyze the student performance data, explore relationships between the factors previously mentioned, visualize important trends, build a predictive linear regression model, and identify which factors have the most influence on academic success.
Assalamu alaikum. Hello everyone. My name is Ali Buhamad. Today I will talk about dataset description. First, the dataset source. This project used the student performance dataset obtained from the Kaggle. So the dataset contains 1 million student record and 6 variables. Each record represents an individual student. So the student ID is a unique identifier. It is a numerical, and the self-study hour is a number of hours spent per a week. So it is a numerical. The attendance is given as a percentage. Also, it is a numerical. Participation given as a score from 1 to 10. So it is numerical also. Total score also numerical. Finally, the grade from A to F. It is categorical.
Hello everyone, my name is Ali. In this presentation, I will discuss the data cleaning and pre-processing stage of our project. We first checked the database for missing values using Python and found out that there were no missing values in any of the variables. This meant no imputation or data removal techniques were required. We then checked for duplicate records and found that every student record was unique, so no duplicate rows needed to be removed. Next, we performed outlier detection using z-score analysis. Although some outliers were identified, they presented realistic student behavior, such as expectation, high-performing student, or student with very low attendance. Therefore, we decided to keep this observation in the dataset. We also verified the data types of variables and confirmed that they were already stored in the correct form for analysis and modeling. Finally, we reviewed whether any data transformation was required since the data set was already clean, and we structured no normalization, encoding, or pre-processing steps were necessary. Overall, the data set was of very high quality and required minimal cleaning before moving on the statistical analysis and predictive modeling.
Hello, my name is Muhammad Akroof. I did the section 5, and for the first part of my work was calculating descriptive statistics for all the numerical variables in the data set, including weekly self-study hours, attendance percentage, class participation, and total score. I calculated the mean to find the average value, the median to find the middle value, and the mode to identify the most common value. Then I calculated the variance and the standard deviation to measure how much the values were spread out around the average. Finally, I found the minimum and maximum values to identify the range of each variable. For the rankings, in the second part, I ranked the students based on their total scores. I sorted the dataset from the highest score to the lowest score and selected the top 10 and bottom 10 students. This helps identify the highest performing student and those who may need additional academic support. And for the last part of the assignment, I calculated the standardized scores, also called z-scores. I used the mean and the standard deviation from the previous section and applied the z-score formula to the total score. The z-score tells us how far each student's score is from the class average. Positive values indicate above average performance, while negative values indicate below average performance.
My name is Hamid, and I'm going to talk about visualization. Let's start with the histogram. This chart illustrates how final total scores are distributed across our entire student cohort. As you can see, the data is heavily concentrated toward the higher end of the scale, creating a left skewed or negatively skewed distribution. This tells us that a significant majority of the students achieved high proficiency, with the most dominant scores heavily clustering between 80 and 100 points. Next, we have a bar chart comparing the average total scores against final grade classifications. This chart serves as a structural validation check for our dataset. We can observe a clear progressive step-down pattern where grade A students hold the highest average score, following sequentially by B, C, and D. This confirms that our categorical grading boundaries are perfectly aligned with the underlying numerical scores without overlapping anomalies. Moving on to scatter plot to explore the direct bivariate relationship between student attendance and their final score. The distribution reveals a compelling pattern. While a massive cluster of our highest scoring students maintains exceptional attendance records near the top right. We also see a wide vertical spread of scores across different attendance levels. This implies that while strong attendance is a frequent trait among top performers, it isn't the sole driver of success, meaning independent metrics like self-study hours likely play a major compensatory role. We transition to box plot to explicitly map out score variations and identify outliers across individual grade tiers. This plot beautifully highlights how tightly packed the scores are within each grade category. The horizontal line inside each box represents the group median. Notice how the boxes are narrow with zero vertical overlap between categories. This low intra-group variance proves that students within the same letter grade perform with remarkably high consistency. Finally, we have our correlation heat map. This matrix calculates Pearson's correlation coefficients to give us a definitive statistical summary of how our variables interact. Using a cool to warm color gradient of value +1 indicates a perfect positive linear relationship.
The results of our data analysis showed that weekly self-study hours were the strongest predictor of academic success. Meanwhile, attendance and class participation showed very weak correlations with the overall grade.
Salam, my name is Abdulwahab Shiha and I will explain the regression model. We used a linear regression model to predict students' total scores based on the previously mentioned factors. Linear regression works by assigning a coefficient to each variable to measure how much it affects their final score. As shown in the table, study hours had the largest coefficient, making it the strongest predictor of grades. Meanwhile, attendance and participation had little to no impact. Our model achieved an R-squared value of 0.66, meaning it explained 66% of the variation in student scores.
In conclusion, self-study hours are the dominant driver of academic success. Attendance and participation showed negligible impact. Our linear regression model was reasonably strong, with an R-squared of 0.66, that institutions such as schools and universities should prioritize promoting independent study habits over putting a focus on attendance and in-class participation. Thank you for listening.